Okay, so we can generalize the nth roots of complex numbers, but then the square root of a complex number has special importance because it is used widely in practical applications. And of course, there is cube roots of a complex number also, especially the cube root of the complex number 1 and cube root of the complex number -1. But then that's for later on. Right now, we'll just study the general square root of a complex number. Suppose we have a complex number a plus ib and we want to find the square root of the complex number. What does this mean? What do we mean by when we are finding out the square root of a complex number? Again, so the geometrical meaning of this will be discussed later on. It does have a geometrical meaning as well, but then speaking in terms of pure complex number algebra, how do we find out the square root of a plus ib? So well, we assume that the complex number a plus ib, when we take its square root, it will result into another complex number, and we call this complex number x plus iy. Now we square both the sides so that a plus ib is released from the square root sign, so that we are able to find out the values of x and y in terms of a and b, right? A and b are the known quantities, right? And x and y are the unknown quantities. So when we let square root of a plus ib be equal to x plus iy, then we can square it and make some algebraic manipulations and calculations in order to find x and y in terms of the known quantities a and b. And so this can be applied when we are faced with a real example having real values of a and b, not just the symbols a and b, right? Let's take a look at the theory behind this. Let x plus iy be equal to the square root of the complex number a plus ib. So what we are trying to do here is trying to find the square root of the given complex number a plus ib. We don't know what the square root of this given complex number is. We only know that the square root is also a complex number, so we let it be x plus iy. And squaring both the sides, I will get x square plus y square plus 2ixy plus a plus ib. Okay, so here it will be x square minus y square and not x square plus y square. So just make that correction. X square minus y square is equal to a, and 2xy is going to be equal to the real number b. Okay, now in order to find out x and y, what do we have to do? We have to first find x square plus y square so that we are able to isolate x square and then take its square root. So we use the algebraic identity that x square plus y square the whole square is equal to x square minus y square the whole square plus 4x square y square. Now how do we get 4x square y square? Well, by the first step of comparison, we got a as x square minus y square and b as 2xy. So when we square both the sides, we get x square plus y square the whole square is equal to x square minus y square the whole square, which is equal to a square, plus 4x square y square, which is equal to b square. So x square plus y square is going to be equal to square root of a square plus b square. So now we have two equations. X square minus y square is equal to a, and x square plus y square is equal to root a square plus b square. So then from this, how do we find out a and b? Sorry, how do we find out x and y? By first adding the two equations, in which case the y square will get eliminated and we'll just have an x. And so therefore, we'll have 2x square is equal to a plus square root of a square plus b square, right? But that is the square of x. So in order to find x, we'll have to take the square root of that as well. So then we get x is equal to plus or minus half of root of a square plus b square plus a. It will have two values. Yes. And then in a similar manner, by subtracting those two equations, you get y is equal to plus minus half root a square plus b square minus a, right? And so x plus iy is equal to root of plus minus root of half root a square plus b square plus a plus I into root of half root a square plus b square minus a. If b is negative, we get a minus sign between those two square root terms. So this is how we find the square root of a complex number. Let's take a look at an example which illustrates this. X plus iy the whole square is given as 7 plus 24i. Find the value of 7 plus square root of minus 576 to the power of 1 by 2 minus 7 minus square root of minus 576 to the power of 1 by 2. Now, it's easy for me to realize that 576 is the square of 24, and so I can write it as 24i square, because minus 1 is minus 576 can be written as 24i the whole square, which gives us minus 576, and so it's easy to write that as 7 plus 24i minus 7 minus 24i, but then I'll go about it in a systematic algebraic manner. X plus iy therefore is equal to the square root of 7 plus 24i, which means x square minus y square plus I into 2xy is equal to 7 plus 24i. So this gives us x square minus y square is equal to 7 and 2xy is equal to 24. So x square plus y square the whole square is going to be equal to x square minus y square the whole square plus 4x square y square. So this is equal to 7 square plus 24 square. So this is equal to 49 plus 576, which is equal to 625. So this gives us x square plus y square is equal to plus or minus 25, because 625 is the square of 25. So now we have x square plus y square is equal to plus minus 25 and x square minus y square is equal to 7. So we get 2x square is equal to 32, or 2x square is equal to minus 18, right? So therefore x square being a real number, its square cannot be a negative number, and therefore we will choose x square to be equal to 32 by 2, that's 16. So therefore x square is equal to 16. So x will be equal to 4. And if x is equal to 4, then y will be equal to 3, right? And so now we have the value. So now how do we find out the square root of this? So 7 plus square root of minus 576 to the power of 1 by 2 is equal to the square root of 7 plus 24i, right? And so square root of 7 plus 24i is equal to x plus iy. That's what? 4 plus 3i. Okay, and similarly 7 minus square root of minus 576 to the power of 1 by 2 is equal to the square root of 7 minus 24i. So that's equal to x minus I y. So therefore that will be equal to 4 minus 3i. So therefore the square root of 7 plus square root minus 576 minus the square root 7 minus square root minus 576 is equal to minus 3i, so that's minus 6i, and option A is what we get for this.